Assalamualaikum and good day to all students. This video is for Program Kecemerlangan Akademik KMNS, Score Program Semester 2, Session 2021-2022. In this video, you will be shown how to solve questions from PSPM 2019-2020, Chemistry 2, SK025, question number 3. Question number 3A. The standard reduction potentials for copper, chromium and nickel ions are given below. Question 1. Arrange the metals in order of increasing strength of reducing agents and give your reason. In order to solve this question, students need to know that the strength of reducing agents are dependent on the value of the E naught. If the value of E naught getting more negative or decreases, the tendency of the species to undergo oxidation increases. So right now we are talking about the species that lies on the right hand side of the equation. We are talking about the species that lies on the right hand side of the equation. So the more negative the value of the E naught, the species on the right hand side of the equation will have the higher tendency to undergo oxidation. Therefore, chromium is the strongest reducing agent. Vice versa, the more positive E naught value, meaning that this species on the right hand side will have the lowest tendency to undergo oxidation. Therefore, will have the lowest strength as reducing agent. So, in order to arrange increasing strength of reducing agent, we go from the more positive E naught to the more negative E naught. So, copper solid, nickel solid and chromium solid. And these are the marks for this question. Next, question number 2. Determine whether the reaction given below is spontaneous under standard conditions. So given this equation, students need to identify which half equation is the reaction at anode and which half equation is the reaction at cathode. So copper 2 plus become copper solid, so copper 2 plus undergo reduction at cathode. Vice versa, chromium solid become chromium 3 plus aqueous, so chromium undergo oxidation at anode. By using this equation, E naught cell equals to E naught cathode minus E naught anode. Insert the E naught given by this question, 0.24 minus negative 0.74. You will get E naught cell value to become positive 1.08 volts. Now, because E naught cell is positive, which is larger than 0, the reaction is spontaneous. So these are the marks for this question. Question number 3. What will happen if chromium container is used to store copper sulfate solution? So this question is actually related to the previous question which the equation has been given. Copper 2 plus aqueous react with chromium solid. So when you use chromium container to store copper sulfate, the reaction was spontaneous as we have calculated from number 2. So the copper metal or copper solid is going to be produced as the copper 2 plus ion will undergo spontaneous reduction. So first, copper metal is deposited. At the same time, the chromium solid will undergo spontaneous oxidation. So it will become chromium 3 plus aqueous. So the wall of the chromium container will dissolve, or we will see them getting thinner. So these are the two answers. So there will be these marks for this question. Moving on to question 3B. Zinc plating or galvanizing is an important means of corrosion protection. One of the possible ways in which this can be achieved is through electrolysis. How many grams of zinc can be deposited on a steel object if a current of 1.2 ampere is passed through zinc sulfate solution for 1 hour? To start solving this question, students need to use the Faraday's law of electrolysis equation, which is Q equals to IT. I being the current and T being the time in the unit of seconds. I is 1.2 ampere and the time is 3600 seconds. So Q is 4320 coulomb. This is the charge that went through the electrolysis. Next, reduction at cathode. Zinc 2 plus aqueous receives 2 electrons to become zinc solid. So 2 mole of electron has gone through the electrolysis. Therefore, it means that 2 multiply 96,500 coulomb equals to 1 mole of zinc. Solving using stoichiometry equation, if 4320 coulomb, 4320 divide by 2 multiply 96,500 multiply 1 mole. So we get the number of mole zinc 0.02238 mole. Lastly, to convert the number of mole into mass, multiply by the molar mass of zinc, which is 65.4 gram per mole. So we will get 1.46 gram of zinc that has been deposited. So these are the marks for this question.